Hi, welcome to JSpring Digital 2021. It is a pleasure to be here online with you. We're here today to discuss some ideas for spring cleaning your Java projects. Normally when I think of spring cleaning, I think of things that I'm aware of that I know need to be done, but are things that I've put off for one reason or another. Either I just didn't have time or I didn't think that there would be any immediate benefit, but things that definitely come up again later that are definitely become a requirement for me to do. I have a couple of closets right now for sure that need to be dealt with, and some paperwork that would really make my life a lot easier if I would actually do my spring cleaning. So some background about me. I'm Melissa McKay. I'm a developer advocate with JFrog. I've been in this position for about a year and a half, coming on a year and a half now. I just celebrated my year anniversary. Prior to being a developer advocate, I was a developer for 20 plus years, various teams, various levels, various organizations, lots of experience there with different languages and different kinds of projects. My expertise has been Java server side mostly. So that's generally what I lean toward given the option. I'm also a Java champion. I'm a Docker captain. You can reach me at Twitter at Melissa J. McKay, and I've also listed my LinkedIn information here for you as well. All right, jumping right in, why should devs care about DevOps? I'm asking this question because our Spring to-do list in this context has a bit of a DevOps slant to it, some processes and improvements that you might want to make. So why should devs care about DevOps? Well, let's start with the definition of what DevOps actually is. And I'm not going to get too fancy here. I'm just going to tell you one straight from Wikipedia. DevOps is a set of practices that combines software development, dev, with IT operations, ops. It aims to shorten the system's development lifecycle and provides continuous delivery with high software quality. That's a fairly good definition. It's basically the idea that some of the walls between a development team and an operations team need to be rethought. It does not mean that a developer needs to be an expert in ops or vice versa. It's more about improving the communication, managing expectations, and working together toward the same goal. My experience with being on a DevOps team was actually relatively recent. I spent most of my career in that development silo. I focused mainly on the code, on writing the code. I would check in the code, and that was it. I wasn't really involved in the pipeline process. I wasn't involved in deploying it. Certainly wasn't involved in being on call for when there were production issues. I would only get involved when there was a bug already specified or a feature that had already been thought through. That's when I would come in as a developer. When I joined a DevOps team, that was pretty eye-opening to me. At first, it was overwhelming because there are a lot of tools I was not familiar with, like automation tools, the software build tools. I was familiar with Jenkins, but there were others that I was not familiar with that I needed to learn. Managing secrets, a lot about deployment, the actual deployment in the cloud, as well as on other infrastructure that we had. There was a lot of networking principles that I needed to learn. But the advantage was I was on a team with operations people as well. So again, I was not expected to be an expert in all things operations. I had a team that I could lean on, that skill set was available within the team. So that was really interesting for me, especially when it came down to observing our software in production, observing how it ran, how it was deployed, being involved in deployments, also being involved in any incidences where production was down for some reason or some bug needed a hot fix, things like that. It made a difference in how I developed. Being involved on a DevOps team, especially with realizing how our code was being deployed, made me code differently. I started to make different decisions on how the architecture of the project, how it was built, how it was put together, because I understood better of how it was actually being used in production. That makes a huge difference. And lots of improvements can be made, and I can definitely say that it came from being involved on the DevOps team. So during this session, I'm going to focus on 3 specific areas all under the umbrella of DevOps for our spring cleaning. We're going to talk a little bit about resource control, about your build, and then about your pipeline in general. But I'll also give you some ideas on how to compose your own list as well, so that you can include things that your team cares about more than what I've chosen to talk about today. I want to leave you with this resource. When I joined my DevOps team, I was given this book to read. And it's called The Phoenix Project. It's an executive's perspective of a software project, and it's written as a novel. It's not like one of the typical software to-do manuals or anything like that. It's been a few years since I've read this book, but it's time to reread it. I just remember the first time through, there were a lot of aha moments, a lot of points where I was empathetic and just understood exactly how everyone was feeling, the problems that were happening, and then the solutions that were implemented. They were it's a very creative way of showing how to make a DevOps team successful. It definitely reflected many of the projects I've worked on over the years. There is a sequel to that book called The Unicorn Project. This one is also a novel, has a lot of the same characters from the first book, but it's actually written from the developer's perspective. So I definitely empathized even more with this book. It introduces the 5 ideals. These are excellent concepts. It's a really creative way of approaching these ideas. I guarantee that after reading those books, you will come out teeming with ideas on how to improve and change your existing processes. But before you jump in and start implementing a bunch of new processes, get together as a team and determine what your values and goals actually are for your software project. This would be a whiteboard session. This is definitely, you don't want to jump in and start doing a bunch of stuff without having this interaction with the entire team and being on the same page as to what you have planned. You can get pretty bogged down, especially when you start adding process to a project when you're not used to it. And there are limits. You don't want to add too much. You want to make sure that you're doing what makes the most sense for your project. Understand that each project is different. You will have different goals. Think of your software development lifecycle itself as a product. Consider the processes that you take to get your product to production in minute detail. Find the waste. What is slowing you down? What's slowing everyone else down? Where are those bottlenecks? Part of this is going to be determining the priorities. What's the worst bottleneck that needs fixing? At what point would you get the most bang for your buck? For your situation, is shortening the time between releases the top priority? Or is there actually a need to focus more on quality of your project or security? All of these things should come up in your whiteboard session, and you can use those questions as guidelines to help you brainstorm. This is a picture of my car. And unfortunately, this little car is sitting in my garage right now. It's pretty old, going on 18, 19 years now, I think. Anyway, it's old enough that when I recently got into a little accident, not serious, no one was hurt or anything, but I ended up with a dent in my door. I was not about to go and get that repaired at a body shop. I think the cost of the repair would probably be worth more than the car is worth. So I hope you can see where I'm going with this. Not to say that your software project is old and needs to be retired. Although in some cases that might be exactly the case. But I just want you to make sure that you're paying attention to the needs of your project. When you go into your whiteboard session with your team, expect to come out with some pretty high-level goals to start with. For example, we need to make our deliveries faster. Well, during your session, break that goal down into actionable steps. How can you actually make that happen? And quantify them. How fast? How much faster do your deliveries need to be? Do you have a way of measuring that progress? If you make changes without a plan to measure your results, it's going to be really difficult to gauge the value of the work. That translates into difficulty assessing the benefit of spending the time and effort for this kind of improvement, and convincing upper management of its necessity even. Also, even if you commit to the first round of improvements, it will quickly fall by the wayside if you don't have any kind of before and after statistics. So these things, is it fast enough? Is it efficient enough? Reliable enough? Economical enough? In this example with my car, it was good enough to go onto Amazon and spend $12 for a magnetic Band-Aid to put on my door. And that is just a statement saying that, I'm going to be careful where I spend the money. It's got to make sense. The same goes for your software projects. This is a slide that I see often in our corporate decks. I do not expect you to be able to read most of this. But the point of this is just to show the step-by-step of the software development lifecycle, all of the details involved in that. It's really busy. This slide is really busy, but I like it because it does a really good job of highlighting how overwhelming DevOps tooling can be when you're presented with all of the stuff on the market like this. This space is huge and you can get lost in the mix. All of these steps and tools address common concerns across all projects. How do I build everything? How do I test everything? How do I deploy everything? Some of the other concerns are, where do dependencies come from? How do I keep everything secure? How do I include automation to help increase efficiency and reduce human error? As you can see from this slide, there are a number of steps that are taken from end to end, from a developer making code changes to deployment to production. There are a lot of touch points, a lot of potential for improvement, a lot of potential for bottlenecks that can be improved. These are places that you'll need to look with your team and start gathering some statistics on how long it takes to get from one step to the next step. That whole slide can be simplified and broken down into these main core components. And there are DevOps practices around each of these components that can help you achieve your goals. The first, of course, is your source code repository, your single source of truth. Obviously, I would hope that all of you have this already in place. If you do not, this is step one for you. Just forget spring cleaning and get this part done. Next is continuous integration. I'm also going to assume that most of you have continuous integration already set up. This is the whole process of multiple developers being able to check in their code changes to source control, and then having a continuous integration server pull in those changes, build the project, run the tests, and indicate whether those changes can move forward in the development lifecycle. If you do not have this set up, just put everything down and get this one done. This needs to happen. The third, package managers. Obviously, all of your code is not written from scratch. Most of us are dealing with third-party dependencies, other frameworks that are helpful. We aren't starting from scratch. We're bringing all of those in and then building on top of them. All of those need to be managed somehow. And you need to know what exactly is in your software at the end. You need that full build of materials and all of the history in order to do any troubleshooting in case any of those dependencies have changed. Then you have the security scanners. This brings in that sec part of DevSecOps. This part is just, gives you the ability to detect any known vulnerabilities in software that's already out there. Definitely valuable. There are a lot of free products that you can use to get just general scanning of, for example, your Java libraries you're pulling in, or even your Docker container images, making sure that you're not using stuff that's out of date or has known vulnerabilities that can cause you a problem in production. And then, of course, continuous deployment, the automation of your deployment to your production environments, and not just your production environments, but to test environments, if that makes sense for your project. Automating that definitely saves you some time and makes that process repeatable. So that's another important part of DevOps. All right, let's jump into my suggested spring cleaning list now. You've got plenty of material to come up with your own list. Now I just want to share with you some things that I gleaned from my experience that I found really valuable for our teams as we developed together. They saved us a lot of time and a lot of hassle, and definitely increased developer happiness. All right, this is a big one. Is it time to change your source control system or provider or host? I remember back when I was using SVN, and I had moved to another team that was using Git and GitHub. That was a really hard move for me. It's just a different way of thinking about it. I kept wanting to come up with the Git translations for SVN commands that I was so used to using. Although that transition was difficult, it was very well worth it. And one of the reasons is very clear on this slide. You can see how popular Git has become and how the other source control systems just are kind of going by the wayside. They're definitely still in use, but there are less and less people that are comfortable with using them. For example, Mercurial. It's been around a long time. OpenJDK was on Mercurial for a long time. And just recently, I wrote an article in March, actually, about the release of Java 16 and how part of that release included source code repositories for OpenJDK migrating to Git and GitHub. This is a pretty big deal. And it was an interesting read. There's some links in the article that link directly to the JEPs that talk about why they made this decision and just exactly what was involved. It was a big decision because this affects how your developers, the workflow, and they wanted to make sure this wasn't going to be so disruptive that it wouldn't be helpful. And I think they did a pretty good job with this. But some of the other reasons that they gave for moving to Git versus Mercurial was improved clone times. That was one example. And then performance measures and popularity of the GitHub hosting service. They served in May of 2020, they were serving 50 million users. That's quite a community to be working with. Also, they listed the availability of an extensive API that's offered by GitHub that improves the whole development and review process of change sets. So no more did they have to resort to mailing lists alone for collaborating with contributors. I have not yet worked with the migrated source code repositories for OpenJDK, but I'm really interested to see how they have things set up. I do know that they work on a PR process, which we're going to talk about that in a moment. But first, let's agree on a code format. There is nothing more frustrating than looking at a diff littered with changes that aren't really changes. They're just formatting differences. This is a really small thing to do, but it comes with huge benefits. Normally, this decision comes about at the beginning of a project, but I've been on projects where it was a second thought. No one really cared about it. And I just came across all of these irritating things like trying to read diffs clearly. There are some good ones out there. The one I have listed here is Google Java format, pretty well used, commonly used. You can take advantage of the available plugins for the popular IDEs. If you want to clean up a project that is suffering, like the one I was on with inconsistent formatting across the board, I suggest agreeing to agree with your team on a time to make this happen and do it in one swoop, one check-in where the entire code base is formatted altogether. Of course, you're going to want to make sure that your build and test pass prior and that you make the formatting changes and your build and tests pass again before you commit to that. You don't want some other unrelated change going in at the same time because that would be impossible to find later if you need to, or next to impossible. So this is definitely worthwhile. Put this on your to-do list if you don't have a common format with your team. All right, I'm going to come back to this PR process that I mentioned a bit ago. A lot of you may already be using this process, but surprisingly, a lot of teams are not. And I was definitely on teams that were not using this process. I was on a team, and this is not to shame anyone. We actually worked pretty well together, but this is one of the things that would happen that over time, I think this has changed. But how this would work is everyone would commit to a common code base, but there was no intermediate step to make sure that those code changes were okay before they were merged into the main code branch. So what would happen is if you got lazy and didn't run your tests locally, or something was just different with your build on your machine and things passed, but then when you checked it in, the CI server grabbed them and the build would fail. This would happen pretty frequently. I mean, even once a week or so, it's frequent enough to notice and cause havoc in the company. There were a lot of engineers. We were all distributed. A lot of us working on the same code base. So there would be quite a few check-ins. And if you came in the morning and you didn't read your email first before pulling down the latest code, you could potentially be in the situation where an email would warn you, don't pull the latest code because the build is broken. And once you've done that, now you're stuck with broken code until the build gets fixed or until you figure it out and fix it yourself. Those days were called donut days. And if you were the responsible party of checking something like that in, which I believe I was at least once or twice, you were responsible to bring donuts in for the next day to make up for it. That's a pretty unhealthy process, but a lot of us just didn't know that it could be better. And moving to a PR pull request process like GitHub has, just invaluable because now you can push your code, open a PR for that code change, and it doesn't go into the main code base yet. A build runs against your change set first. If that build passes, then you can merge it in to the main code base. Really mitigates that problem of having a broken build across the board for everyone. Another thing to add is pre-commit hooks. Consider putting those in place. Those the local pre-commit hooks are just developer friendly. They're not necessarily enforced, but they are helpful for things like checking for symlinks that don't exist, checking for tests that aren't named correctly. That happened actually, it was quite some time before we realized that a particular test wasn't running just because it wasn't named correctly and none of us caught it. Checking for merge conflict strings in your files. Those are all things that you can do before even starting the peer review process or a pull request process. It would save a lot of time to eliminate those problems beforehand. There are server-side Git hooks that you can put in where you can actually enforce some things. I put some links here on this slide to reference that if you're interested in those. All right, I like this cartoon. How many of you relate to the characters in this comic? I'm not going to read it to you. I'll give you some time to read it yourself. But it's just basically, if the build is broken, just build it again. And this is a result of oftentimes just not really fully understanding how the build is actually pulling everything in under the covers. I remember being on a team once where this happened so often that the permissions to that build button in Jenkins had to be removed because everyone was clicking that button. And the result was it was triggering a ton of downstream builds that some of us didn't even realize existed. So it started all kinds of problems. So building for the sake of building just to get green without understanding what's going on, especially if you have like flaky tests or something that only fail sometimes, those things need to be cleaned up for sure. There are many reasons like that builds might fail, and it's so disappointing when it happens, especially when you're convinced you fixed something or that the build ran just fine on your machine. I'm going to touch on one potential reason that can be particularly painful. Your build is just unreproducible because of differing dependencies. Anyone that spends any time with package managers like Maven or NPM will eventually run into this issue. So what can we do? The first step is to know your build, understand where your dependencies are actually coming from. This on this slide is some output from a Spring Boot project. And this particular project is just a proof of concept. It just has a couple of dependencies listed in the POM file, but it pulls in a ton of stuff with that Spring Boot framework. All of that stuff, as you can see what's circled here, it's coming from Maven Central by default. Unless you set your Maven settings to pull from a private repository, which I would say is worthy of adding to your Spring Cleanup to-do list, unless it's pointed to a private repository, it will point to this public repo. There are many private repositories like Artifactory that will serve as a cache of dependencies that come from third-party sources, and they make your build faster. You also have more control over those dependencies, what users are allowed to use them, who's allowed to download them. You can take that opportunity to scan them for any vulnerabilities, that kind of thing. So if you definitely set up your Maven settings so that they make sense for your project and are pulling from the appropriate place. You don't always want to be pulling from Maven Central, and consider your build in your CI/CD pipeline, whether that is actually pulling from Maven Central all the time as well. That can also be an issue at times. Your private repository may be more reliable. The other picture on this slide is, I borrowed it from a talk on Docker containers when I refused to use any pictures of shipping containers. Instead, I used a somewhat forced analogy of bananas as container images. And I like this picture because there's a ton of bananas there, but you don't know where they come from. They look good, but you don't know where they're coming from. This leads into something about Docker containers that you should be aware of and add changes to your Docker files to your spring cleaning to-do list. So let's look at this Docker file. It was just copy pasted from somewhere. That first line, where is that image coming from? Just like your other package managers, by default, that image is coming from Docker Hub. You can specify a private repository there, but if you don't, locally and on your build server, that is always going to be pulling from the public central repo Docker Hub. The second line, for this particular project, it's not a big deal just because I'm familiar with the project, but it's actually copying the entire source control tree into the image that it's building. This is also not as big deal for this project because this is a multi-build Docker file. So all of that isn't necessarily going to end up in the final production image, but you should never mindlessly do this. Understand what's actually being copied in there and only copy the things in that you need for your project. The third item that I'm pointing out there is we're building this without tests. It looks like we're using the Maven wrapper and we're just skipping tests. Now, why would you do this? This is actually pulling that Maven in because think about it, in your build pipelines, you may have nodes that are ephemeral, that are, they're brand new when they start up. They may not have any cache. So maybe they don't have Maven installed. And this was one way to make that whole process a little easier. You can indicate the version of Java that you want, and you can pull in the appropriate Maven in order to build the project. But the thing is it appears that in this case, we're actually building this project twice. It's the only explanation for skipping tests. Seems like maybe earlier on in the pipeline, the project is actually built, but then that artifact isn't being used in this Dockerfile. So that's something to consider. You only want to build once in your pipeline, and that one build needs to pass all of your quality gates in order to become a valid release. So add these to your to-do list. Is automation worth the time? Let's talk about automation. It's often proposed as the solution to all of our problems. XKCD is one of my favorite comics. This one is doing some math for you to figure out the point of diminishing return on making a routine more efficient. Humans are horrible at repeated tasks. We get bored, we get complacent, we always miss something. You should automate what makes sense. So you need to, automating your build makes sense, for example, both locally and in your CI/CD pipeline. Consider how many times a day builds are run. Automating setting up a development environment, that's another thing that's worthy of working on. Automating tests, both unit and integration tests. Some suggestions for that automation is use a bot account. Don't use a user, like one of your team's user accounts for any of this stuff. You want those user responsibilities to be separate. It needs to be clear what your automated systems are doing versus what your team members are doing. You don't want to deal with build failures simply due to user credentials expiring or a user choosing to change their password when they see fit. And then for automating tests, running tests take time. Consider running them in parallel. Consider breaking up those tests by module and only run the tests that are relevant to changes in a particular module or a component. Consider only running smoke tests for each build and all tests in your nightly build. These are all efficiency measures that you can take to improve your build times. Is any of this worth time? Another XKCD comic about automating the delivery of condiments. I'm going to read the title text for this one out loud. I find that when someone's taking time to do something right in the present, they're a perfectionist with no ability to prioritize. Whereas when someone took time to do something right in the past, they're a master artisan of great foresight. This really made me laugh when I read it for the first time. I find this especially holds true in my experience with automating and making tests more efficient. It takes time, but it is usually time well spent. I would suggest dedicating one team member for improvement and efficiency tasks per sprint. And don't forget to measure the results. Okay, just to recap our spring cleanup to-dos. Determine your bottlenecks with your team. Consider switching out your source control. Implement the use of a style guide, a common formatter. Decide on a commit format and implement pre-commits. Evaluate and improve your code check-in PR process. Manage those dependencies, both locally and in your build pipeline, and ensure that you're only building once. Set up a bot account or an ops user. Seems like a pretty small task, but you'd be surprised how often you need a user of some type to run particular automation. Automate what makes sense, and then devote someone for maintenance and improvement. And don't try to tackle all of the things at once. This is a big list. I have a feeling that some of these are already known by your team. It's just low priority, and sprint after sprint goes by without any of these tasks getting looked at. But don't get overwhelmed. Any changes that you make are incremental improvements over time. And if you stay with it, your goal of improving by 1% will turn into something more substantial. Remember to measure your results. Retrospectives are going to be very important here. Make sure to include both tangible and intangible benefits. That means developers that are feeling less frustrated due to changes that you've made is worth documenting, along with actual numerical data. That's all that I have to share with you today, but my challenge for everyone here is this: pick one of these things to do for your next sprint. And depending on the size of your project, you might even need to break those tasks down even further, but pick one and see how it helps. All right, thank you, everyone. I'm looking forward to Q&A with you all.